Hello. We're going to look at section 6.2 today. And this is going to be a kind of a short section here, mainly because we're going to be prepping ourselves to use these things we're going to talk about today in future sections. So I think the concepts, once you get a hold of them, they're not that complicated, but I don't want to go too fast over this because it's going to be very critical you can do it in the future sections. All right, so we're going to look at the idea of standard areas or standard units, and then areas under the standard normal distribution, Okay, so the standard score, or sometimes called the z-score or the z-value, it describes how many standard deviations, whatever number you're looking at, is away from the mean, either above or below. That's what the z-score tells you. It tells you if you're like 3 standard deviations above the mean, 1.5 standard deviations above the mean, 0.2 standard deviations above the mean. How many standard deviations or below the mean, above or below, you could possibly be. And the way you calculate that is use this formula. So again, we probably recognize some of these things in here, but let's just kind of remind ourselves. So mu is the mean, specifically the population mean, right? At this stage, that's all we're going to use. We're just going to use the population mean. Sigma is the standard deviation, how big a standard deviation is. Again, this is for the population. At this point, that's all we're going to worry about right now. X is called the raw score, or the actual value we're looking at here. And then Z, that's your z-score, or your number of standard deviations. So, you know, if a standard deviation is size, let's say 5, and my mean is 150, and my value is 155, well, that's 1 standard deviation. Z would equal 1, right? So think about like the standard deviations, how big a step is. On the other hand, if my X value is 152.5, well, that's half of a standard deviation. So my Z value would be 0.5. If my X value was 147.5, again, that's a standard, that's half of 1 standard deviation, but it's going the other way. So my Z value would be negative 0.5. Or if it was 145, again, that's 1 standard deviation, 1 step. So my Z value, but it'd be down, so that'd be negative 1. So that's what the Z is telling you, is how many standard deviations you are away from that, whatever mean you're talking about, whatever value that is. All right, so what is the Z-score of the value of 115 if the normal distribution has a mean of 130 and the standard deviation of 8? So again, we're going to say, okay, that Z-score is the value minus the mean over the size of a standard deviation. So what's the z-score of 115 if your mean is 130, if your size of your standard deviation is 8? Or in other words, if you are 15 units below the mean and every 8 units is a standard deviation, how many standard deviations is that below the mean? So it's going to be a negative, this is below the mean, negative 1.875 standard deviations below the mean. Okay. Another thing you could do with this is you could get told your Z value and then ask, okay, well, where are you? What is the value you're at? What's the actual value? What's the raw score? And so we could do, let's do it without the formula, and then we'll do it with the formula. So this is telling me I'm 1.5 standard deviations above, and it's above because this is positive. Okay, well, every standard deviation is size 8. So 1.5 standard deviations, 1.5 times 8, that's 12 units, 12 actual units above the mean. So it's above the mean. My mean is 130. So I must be at a value of 142. That must be where I'm at. And if that standard deviation had been negative, it'd be below the mean, and I would subtract that off of 130. Now, I can do that with the formula, and it's some algebra. I could just say 1.5 equals x minus 130 over 8. Solve for x. So get rid of your fraction, multiply both sides by 8. 8 times 1, these 8s will cross off. 8 times 1.5 is 12. Get 130 by itself, add 130. And boom, there you are. Right back to x equals 142. So you can kind of think about it, like I know how big a step is. On 1.5 steps, that direction, either added or subtracted to the mean. That's how you could calculate the actual raw score. Be careful you don't confuse the raw score for the z-score or the z-score for the actual size of the steps for standard deviation and stuff. But that's how you convert an actual value into a number of standard deviations. All right, I want you to do problems 1, 2, 3, and 5. Pause the video, and then we'll come back for part 2 of this section. Okay, so let's talk about part 2, and then we'll be done. This is a short section. Like I said, we're setting the groundwork for future sections. So we talked about normal distributions and the empirical rule. That still applies, but now we're looking at what we call a standard normal distribution. And the standard normal distribution, to standardize everything, we're going to call the mean 0. We're going to say it's centered at a value of 0. And then the size of our standard deviations, we're going to call 1. So if you're at a value of 1, you're at a standard deviation of 1. If you're at a value of -2, you're at a standard deviation of -2. So the z-score and the value, the raw score, are the exact same thing with this standard distribution. They're the exact same thing. So z-score and the raw score for a standard normal distribution are the same exact things. And where we're going to go with this is we're going to convert non-standard, but still normal, still bell-shaped curves into this. And then we're going to figure out some probabilities. That's where we're going to go in the future section. But today, we're keeping them separate. We're not mixing them yet, but we're keeping them separate. But that's where we're going. That's what we're sounding the groundwork for. Okay, so this is our normal distribution. Same thing, empirical rule still applies, 68%, 95 within 2 standard deviations, 9.7 within 3 standard deviations. Okay, that still applies. All right. Now, on the course page under modules, go under modules. I think it's like course materials I put in there. I think that's what I called it. Can't remember right off the top of my head. I put a PDF called stat tables for you. I would print those off. There are 4 tables. We're going to deal with the first 2, but eventually we'll deal with all 4. But I would go ahead and print them off, just kind of stick them in your book or in your notes. These are in your textbook. They're in the table section in the back, but it'd be just easier just to have a paper copy. We're just going to keep referring to them over and over again. So you'll want to have those. All right, so this first table, how it works, and you kind of see from this diagram, you're going to have a z-score or standard deviation score of something, and the table is going to tell you how much area is under the curve from there and down. From there and down. The first table, you're always going to be dealing with values below the mean. So they're always going to be negative values, and from there and down. Okay, so that's how that table is. And that's going to correspond to probabilities, because the area under the curve is going to be the probability you get a value within that shaded area. So let's say we wanted to go, what's the probability of getting a value less than or equal to negative 2.59? So this is how I would do that. So let me draw the picture and then I'll, draw a little picture here. And it's way down here, right? Negative 2.59. And I want to know what's the probability I'm in this little tail end here. Okay. So the way I do that is how the table's broken up is it has the first two values and then the second value. So I'm going to come down on the left-hand side. I'm going to find the first two values, negative 2.5. And then along the top, it has the second decimal place value, the third number there. And I just cross-reference this to find this is how much space is under the curve from there down, or what is the probability you get a value in that area. Okay. Now, the curve is symmetric. That means the left and the right-hand sides are exact duplicates. With that in mind, I could use this to figure out what's the probability I'm bigger than positive 2.59. So, if I kind of draw a little picture about that, it looks like something like that. I'm down here at 2.59, and notice they're both 2.59. This little tail end has to be exactly the same as this little tail end. These tail ends have to be the same since they're the exact same number of standard deviations and we're going outwards in both ways. Now, neither of the two tables, the first two tables, that's what we use for this, go up. They always have the area go down. So I can figure this out by taking this little tail end and saying, oh, well, it's got to be the exact same thing as this one. That's the easiest way. Now, there is another way we're going to be able to do it, and that is you could say, well, everything is 1, and then I could use the second table. Second table is going to give you positive values and cut off all that, and what would be left is that, cut off whatever that is, and that would be that number. You could do that, but this is actually easier. If you just understand that it's symmetric both ways, you can do that. All right, but let's talk about the other table. So the other table uses values above 0. So Z values or standard deviations bigger than the mean. And in that case, again, it's always from that value down, so if I want to say, what's the probability I get a Z value of 0.73? Again, I'm just going to, just like before, well, here, let me draw the picture so we're clear. So what we're looking for. So this is somewhere, I don't know, if that's the mean, this is probably about here. 0.73 standard deviations above the mean. So remember with the standard, the number of standard deviations and the number of steps are exactly the same thing. So I'm looking for this area. That's how this diagram is set up. And so 0.7 is the first two, and then 0.3, that's the second one. And again, I just cross-reference those. So the probability I would get a Z value of 0.73 or lower would be 0.7673. Okay. And so just like I was talked about before, you can use this to do a symmetric problem as well. You could say, well, what if I wanted to be, figure out negative 0.73 or lower, or sorry, 0.73 or higher. Again, neither table goes up. Both tables go down. And so I couldn't do this directly from the table, but I could say, well, okay, that's got to be symmetric to this. These two have to be the same amount under that curve because the curve is symmetric. So this one would also have to be 0.7673. And just like I said before, you could, if you wanted to, take, the whole area is 1. You could subtract off, this little tail bit, and that would tell you this amount if you wanted to do it that way. But this is easier if you in faster. If you just kind of say, well, it's a metric. What would it be if it was a mirror image? How would I figure that out? Well, I'll just flip it around and okay, it'll work that way. If that makes sense to you, I don't know. All right, find the indicated probability and shade the corresponding area under the standard normal curve. Okay, so I want to find this probability. So this is where you want to have those tables out handy. So if you need to pause it, print those off before we get into this, go ahead and do that. So what are we doing? 2.34, negative 2.34 down here. And then 1.98 is about where it switches on the inflection point, 0.98. And what I want is this, what's the probability I'm in this area? What's this area under the curve? That's how this works out. What's the probability I get some value in here? So what's the area under this part of the curve? Now, again, the curve is not set up for this. The curve is set up to go from here down. That's the second table. And the first table is set up to go from here up. And what I want is that. Well, what that is what's the probability z is less than or equal to 0.98? That's from that all the way down. And I want to subtract off what's the probability z is less than or equal to negative 2.34. This little, I want to subtract this little tail section off. I want to take that off. And what will be left is that space in between. So I cross-reference on the second table. That's using numbers above the mean, right? The mean is, in here. This is where the mean is, 0. For the standard, it's 0. Okay. So this is above there. I use the second table, and looking on that second table, it looks like that value comes out to be, to me, 0.8365. Looking at the first table, cutting off that little tail there, the amount of that little tail is 0.0098. Subtract those, 0.8365, oops, 0.8365 minus 0.0099. So 0.8266 is a probability you will fall in between those two numbers, Okay. All right, so for the rest of the assignment, 23 through 37, finding those probabilities. Like I said, not a lot to talk about today, but there's a lot of practice you need to do because this is going to come into play in the next rest of this course. Basically, we're going to keep doing this stuff over and over. So make sure you can calculate z-scores, make sure you can calculate areas under these curves, and try to think of them in different ways. And that's why they want you to draw the picture, so you have a visualization of what am I doing, and maybe you can, like, from here up, or that's a mirror of there down, and however you can think about it. So I will talk to you later.